Thank you very much. Hey everyone. Thanks for joining. Good to see everyone at Nodes. I think I have been a part of every node since they started, so that's super fun. I dropped a link to the slides in the chat here. Feel free to grab those. There's some links and resources that you might find useful. You can also scan that QR code. So my name is Will. I work on the product team at Neo4j with a focus on AI innovation initiatives. Some folks might have seen me around the Neo4j community before. I used to work on the developer relations team for a while, and then the last 2 years I've been working in a few different AI startups, and recently back to Neo4j on the product team. So good to see everyone there. There's some links to get a hold of me too if you want to. Feel free to reach out. Happy to chat with folks. So the title of this when I pitched it was "The fastest path to building an agent for your knowledge graph is by using Neo4j." That was several months ago when I proposed it. I think now if I would say what's the fastest path to building an agent for your knowledge graph is by actually creating an Aura agent. I'm curious. Let me know in the chat. I'm really curious, like if anyone has tried Aura agent yet. This is still in preview, but it's available in Aura. Sign into the Aura console and you'll see it there. This is a really neat way to create agents that have tools. So text to cipher tool, we can create cipher templates or just really simple similarity search and create an agent that can access those tools that are capable of querying your database, and then they're exposed in an API. So if I was going to build a talk today about the fastest way to build an agent for your knowledge graph, this is probably the route I would take. So definitely read this blog post. I think Ed had a talk today on Aura Agent. I might be mistaken, but definitely check that out if you're interested in creating agents for your knowledge graph. So really, I think maybe a better way to frame this talk is we're going to talk about MCP agents and graphs with Neo4j. So we'll do a brief overview of Neo4j. Are folks familiar with Neo4j? I see. Or sorry, are folks familiar with MCP? Is rather what I meant to say. I see a few folks in the chat say that they did the training yesterday for Aura Agent. Cool, that's awesome. But yeah, let us know in the chat. We can kind of level set there on MCP. But then really, I want to talk about the Neo4j MCP ecosystem, how we can use MCP servers that can connect to Neo4j for different ways to use those with agents, and then we'll look at how you can build your own MCP server, and then of course we'll talk about some of the challenges of working with MCP and how to think about that. And feel free to keep the session as interactive as possible. I can see the chat here, so feel free to drop that in. Any questions or feedback, thoughts you have. There are also some Neo4j folks in the chat as well. Cool. So if we take a step back, this blog post, this was Building Effective Agents, published by Anthropic almost a year ago. So I think this was December of last year. And I think this was a really influential blog post to kind of set different frameworks for how to think about building agents. And it goes deep into different patterns for sort of multi-agent coordination and that sort of thing. But really, I think there's this important concept at the heart of this idea of an agent, which is the augmented LLM, right? So an LLM just has data knowledge that it was trained on. Of course, we need to bring more recent, more relevant, maybe private enterprise data to the LLM. We also, to have a true agent, the agent needs to be able to understand and interact with its environment. And it does this through the use of tools. So tools, you can think of this as like functionality functions that we've given to our agent to be able to interact with its environment. If we extend that concept a little bit and look at like what does a rough architecture for your typical agent look like, it's something like this. There's an orchestration layer that's orchestrating like user messages, system prompts, tool calls with your LLM. How do we use tools? Well, we use it to interact with external services. Like maybe I'm building an agent that has access to my GitHub and is going to, I don't know, post messages in Slack when I do a release or something like that. Retrieval is also an important piece of this, right? How am I going to fetch relevant data based on the user message, based on the query? And that also is done through tools, the ability for the agent to interact with its environment. And now these tool calls, so the access to tools, models choosing to invoke the tools, that happens in the agent loop. This is typically a three-stage loop. And think of this as the typically called the React loop. So there's reasoning, action, and then observation as a result of the action. And then we go through that loop again. Have we achieved the goal? Can we sort of respond to the user in the loop? No, we need to maybe call another tool. Okay, we have more information, and we reason about that and go through this loop. And so when we're thinking of like the definition or like the heart of like what is an agent, Simon Willison said, an LM agent runs tools in a loop to achieve a goal. That's kind of how we think of it. And that loop is really important when we think about context. So context, this is like additional data that's passed to the LLM when we want to invoke it. And if we look on the left side of this diagram, right, without the sort of augmented LLM, we have a system prompt and a user message. We send that to the model and we get back some response. But now in this agent loop where we have things like tool calling, there actually might be a lot in that context, right? We have tool definitions, maybe we have memory, maybe we have like files and documents that we want to add into the context. All of this sort of starts to add up. When we call those tools, well, the results of those tools also go into the context. And so we need to start thinking about managing what's in our context. And this gave rise to this term context engineering. So regardless, I guess I'm maybe sort of on the left end of this meme here, right? How do we think about agents? Well, an agent is just an LLM calling tools in a loop to achieve a goal. And MCP is one of the ways that we can expose tools to our agent. So let's do a brief overview of MCP. MCP, Model Context Protocol, is a protocol for exposing tools and other things. We'll talk about the other things, but think of tools, exposing tools to our models. So the ability to for the model to interact with and understand its environment. Early on, MCP was referred to as like the USB-C of the agent world, and I don't know, that resonated, I think, with some folks. It's basically like a standard interface when you're building an AI application, is maybe a way to think of it. So before MCP, we were all sort of building our own sort of unique bespoke APIs for interacting with external services. MCP comes along and we can just build that MCP server once and then use that as an interface to that service in all of our AI applications. And even better is that someone else, maybe GitHub, for example, can build and publish an MCP server, and then we can use their official MCP server to interact with GitHub across all of our AI applications. So I copied this slide from the deeplearning.ai course. I think this is a really good course that goes a little bit deeper on what MCP is, how do I work with it, but also how do I build MCP servers. So fundamentally, an MCP server exposes tools, resources, and prompt templates. Mostly we're focusing on tools. These are functions that the model can choose to invoke to either fetch data, call an API, something like that. Resources, these are read-only data. This could be something like maybe a bunch of example data models or example cipher queries that might be helpful. And then the prompt templates, these are kind of like prepackaged prompts that we know work well with sort of the service that we're building the MCP server for that our AI application can then use. There are also lots of other interesting features that are in MCP, like sampling, which allows us to sort of send a prompt back to another model. We can sort of evoke and ask for specific information. So definitely check out this course if you're interested in MCP in general. What we're going to focus on today is diving into like the Neo4j MCP ecosystem. So this landing page, this is the MCP page in the developer guides, has information about a bunch of different MCP servers. And so it can be a little confusing and maybe overwhelming, like which MCP server do I want? And roughly speaking here, there's docs for the official Neo4j supported MCP server. And then we have these Neo4j Labs MCP servers. And this is an important distinction. Like Neo4j Labs, these are more experimental projects that allow us to sort of build things, put them out, and validate them with the community. These are not officially supported by Neo4j. There are a lot of challenges, and especially around security and authorization with MCP. So if your requirements need an officially supported MCP server, look for the official MCP server. But then these Neo4j Labs servers, these projects have maybe more experimental functionality. And there are a handful of those. We'll talk about what some of those are in a minute. And then there's documentation on different framework integrations like the Google MCP Toolbox for building MCP servers or integrating MCP servers into all of the different agent frameworks. So the official MCP server, this is currently in beta. I think it's beta 3 now. Earlier today, John and Michael did a talk that showed how to use the official MCP server. So it's definitely functional. You can try it out. There's some releases in the GitHub repo there. The Neo4j Cipher MCP server, this is the one we're going to use today. This allows for exposing the schema and also for our model to be able to execute cipher queries. There's also the Neo4j data modeling MCP server. Jesus and Alex did a talk earlier today using the data modeling server to build an ontology. So this is useful for creating data models, visualizing them. This heavily uses the resources feature. So there are lots of example data models for different use cases. There's also the Neo4j Knowledge Graph Memory Server is one of the lab's MCP servers. Memory is a really interesting topic. We'll talk a little bit about that today. Memory is important for agents to be able to sort of hold states and knowledge across multiple conversations or interactions with the user. Entity extraction and identifying facts and preferences turns out to be quite important. So this is an MCP server that you can add to, say, like Claude Desktop, for example, which will be able to build a knowledge graph of memories behind the scenes. Let's take a look at a few things, like what can we do with the Neo4j MCP server. One is exploratory data analysis. Claude Desktop is a really good MCP host application for this. One, because it has a really nice interface, and also because it has a free version, so we don't need to pay for a subscription to be able to test it out. This is the configuration to add the Neo4j MCP server to Claude Desktop. Basically, what we're using UVX here to run this Python MCP Neo4j Cypher package, and then passing in credentials to our Neo4j instance as environment variables. You can take a look here. Here I've added the Neo4j Cypher MCP server to Claude Desktop in the configuration, and it shows up here. I have a memory server as well that I've disabled, but here's the Neo4j database MCP server, and you can see that there's three tools here. There's fetch the schema, execute a read cipher statement, and execute a write cipher statement. I'm going to go through a conversation that I had earlier so we can see how this works. And so initially my database was empty. I said, hey, what's in my Neo4j database? And we can see here that Claude chose to execute the get Neo4j schema tool and found that the database is empty. It confirmed that by running a cipher query to get a count of the nodes, like, hey, there's nothing in there. And this is where I think working, like learning new tools, iterating on data models, the exploratory data analysis piece is really interesting and useful. So I said, hey, I want to design a knowledge graph for product catalog, customers, order information, suggest a schema. And Claude suggested a schema like nodes, relationships. We can iterate on this. I said, hey, yep, looks good. And now create some sample data. And this is really neat because now Claude is going to execute a bunch of write statements that's just going to load some sample data into my Neo4j Aura instance. And this is really good for like testing and development, right? And then, I can go on and say, hey, what are some questions that I can answer, generate the cipher queries, show me the results, that sort of thing. Claude is also really good about creating artifacts like visualization and these sorts of things. So that's one use case is this sort of exploratory data analysis with Neo4j. Vibe coding is another like really interesting area. I like to think of this more as like schema assisted development. So if we're using something like Cursor, Claude Code, Windsurf, VS Code, in any of these like agent, coding agent or IDEs, we can add the Neo4j MCP server, and then we can leverage that in our coding agent. So our coding agent has access to the schema and the ability to execute cipher queries. We're going to take a look at this using that in a moment for schema-assisted coding in the context of building our own MCP server. So I did a workshop a couple of weeks ago, I think, on MCP with Neo4j. So we're going to look at the example MCP server that we built there. It's on GitHub. I've got it loaded here in Cursor, and you can see here that I've added the Neo4j database MCP server, the same one that I had in Claude. To do this, you can just click Add MCP server and paste in that JSON snippet. And so we have the same three tools here. We have access to the schema, and then the ability to execute read and write cipher statements. So let's take a look at the code here. There in this repo, there's a Python version and also a TypeScript version, both using the official Anthropic's MCP SDK from the Model Context Protocol org. In Python, that is the fast MCP package. There's currently two versions of these. Version 1 in the official sort of Python SDK. There's a version 2, which has some additional functionality that's not. This is using the official one. And so we have some basic infrastructure here, like, hey, we need to create a driver instance. Here's kind of a helper function that executes a cipher statement using the Neo4j driver. And then we want to be able to define tools. So when we define tools, natural language is actually quite important here. So we need to have a natural language description of the tool and its parameters, because this is how the model is going to choose to execute this tool, how it's going to understand what the tool can be used for, and what parameters need to be generated. We have, so this is a search customer tool that has a pretty basic cipher statement and just returns that. And then we have another tool that we've defined here, which is recommend product. So given a customer ID, let's have a product recommendation query and return recommended products to the user. And that's pretty much it, right? We have functions that have some logic. In this case, it's going out and executing a database query, and we just annotate those with this mcp.tool. Let's go ahead and give this a run. So our MCP server is up and running on port 8000, and I'm going to launch the MCP inspector. This is a really useful tool for debugging, testing, and development of MCP servers. So let's go ahead and connect to our MCP server, and we can see here that we can list like resources, prompts that are exposed. Our MCP server exposes two tools: search customer, so we can search for customers. Let's run this tool. It runs cipher query and returns some results. So we found a user, James here. Let's check out the recommend product. I happen to remember James's customer ID is customer 004. Let's go ahead and run this tool. Oh, and we get an error. So we have a syntax error in our cipher statement. So let's jump back to the code here. So this is our problematic cipher statement. And so what I'm going to do here is highlight this. I'm going to say add to chat. So this is going to add these lines into a new agent mode chat in Cursor. And I'm going to say this cipher statement returns an error. Use your Neo4j tools to fix the cipher statement. So this is like a coding agent chat. I've added into the context like the specific problem-specific area I want to debug and improve. And we can see here that Cursor is, okay, great, I need to fix this cipher query. So the first thing I'm going to do is fetch the schema. And then we're going to run some different versions of the cipher statement. And I'm starting to get a diff here. And so there was a syntax error in here. We're going to update the query. And then what's really neat is that Cursor is able to test it. So it's able to generate the query, not just based on the schema, but it's also able to actually test that query and see to make sure that it actually works. And so there's a problem here that we were doing some improper aggregation before we were returning. We can see the results of all these tool calls here. Cool. And it says, hey, this works without errors. Great. And then it's just kind of testing it again. So let's keep all of these. Let's restart our MCP server. We'll launch the inspector again. We can connect again. Tools, list tools, recommend product, customer 004. Run the tool to get recommendations. We don't get any recommendations, but we don't get an error. And the reason we don't get any recommendations is because this user doesn't have any overlapping products that it's purchased. And so I could go back here and say, I didn't get any results for, right? And Cursor will stick in customer 004 for the customer ID and figure out, oh, well, the reason you're not getting any results is because you don't have any overlapping product purchases, and it'll recommend a fallback and so on. So anyway, this is just an example of how we can use the Neo4j MCP server in coding agents to kind of help with schema-assisted coding is the way I like to think of it. AI agent memory is, we were talking about this earlier when we were looking at the knowledge graph memory server. This is a really interesting area. I'm going to kind of skip through here. Definitely check out these slides if you're interested in memory. There's an example project that I built that uses MCP to expose memory search tool and message saving that does init extraction and this kind of thing. So check that out if you're interested to see how that works. Instead, in the last few minutes here, what I want to do is talk a bit about some of the challenges that come up when working with MCP. Some of the biggest ones are working with tool calling models, authorization, and then managing context. So one observation is that not all models are great at tool calling. Our friends at Letta recently published this benchmark, Context Bench, which is, this is deeper than just tool calling. It's sort of like how good are the models at chaining together multiple tool calls and this sort of thing. And we can see here that Claude Sonnet 4.5 is the clear winner here. And if we think about like why this is, well, in order to invoke or request a tool call, the model needs to emit a special token that indicates, hey, I would like to call this tool. And like these tokens, they don't exist out in the wild. And so this doesn't happen during training. This is like a post-training thing that we have to do. And so how good the models are at tool calling depends on, I think, part of it is like how much effort is invested in this like post-training process. Anthropic, I think, has invested quite a bit into this area. The folks at Cloudflare had this observation, right? That like not all models are so great at tool calling. And they have an interesting approach that they call code mode in their agent framework, where they agent framework actually will convert the tools exposed through MCP to a TypeScript API and then spin up a sandbox, and the agent will write code that executes in that sandbox. They found that this improves the tool calling ability of models. Authorization is really a whole area, I think, that is best practices are being identified. There are a lot of horror stories. There's a Docker blog post series that is horror stories of MCP. It's good timing around Halloween. One of the examples is software supply chain injection, where they injected some attack into a popular package that was used as an MCP proxy. So these are things to think about as you're adopting MCP. And then managing context is also a bit of a challenge here. We saw this image earlier where the tool definition and the tool results by default go into the context, which can eat up a lot of tokens. It can also make it more difficult for the model to figure out like which tools to call. And here's a blog post from Anthropic that came out a couple days ago, making this observation that direct tool calling consumes lots of tokens, and they're looking at a similar approach to Cloudflare of agents scale better if you're actually writing code against the tools rather than using this like JSON representation for tool calling. Cool. So we're about out of time here. There are lots of resources out there on using MCP with Neo4j. These are just some of the MCP talks today at Nodes. I think most of these already happened. Look for the recordings on the YouTube channel if you're interested in finding any of these. For the Neo4j MCP ecosystem, this page is going to be your best bet in the developer guides, with links to resources for all the different MCP, Neo4j MCP servers and framework integrations. And then here's some of the tools that we mentioned earlier today. And we are out of time here, so we will stop there. Thanks a lot, everyone.